Solving cubic equations. In this tutorial, we are going to solve an example where given that minus 1 is a root of the equation z cubed minus z squared plus 3z plus k equals to 0. So we have a polynomial of degree 3, the highest degree on z, so we are solving a cubic equation where given minus 1 is a root, so we have the first root which is a real root. For part A, find the value of k. To find the value of k, we are going to use the given root and the polynomial. As minus 1 is a root of the equation, and let's denote this one by f of z. Therefore, f of minus 1 is equal to 0. So if we substitute the value of z to be equal to minus 1, then f of minus 1 will be equal to 0. So we are going to substitute the value of z by minus 1 in the above equation. Minus 1 cubed minus 1 squared plus 3 multiplied by minus 1 plus k equals to 0. Minus 1 cubed is minus 1 minus 1 squared plus 1 plus 3 times minus 1 minus 3 plus k equals to 0. So minus 1 minus times the plus 1 is minus 1 minus 3 plus k equals to 0. Adding these numbers will be minus 5 plus k equals to 0. We are solving a simple equation to find the value of k. We add 5 to both sides, so we get the value of k equals plus 5. So in this equation, we are going to substitute the value of k, which is equal to 5. For part B, it is required to find the other two roots of the equation. As you can see, we have a cubic equation. One of the roots is real, so the other two roots may be either real or complex conjugates. In order to find the other roots of the cubic equation, we shall use the factor theorem, which means that if f of alpha equals to 0, where alpha is a root of the polynomial, then z minus alpha is a factor of the polynomial. The value of alpha given in the question is minus 1, so minus 1 is a root. Therefore, z minus alpha, z minus 1 is a factor of the polynomial, so this one is a factor. Therefore, z plus 1 is a factor. The meaning of a factor is that the polynomial is divisible by z plus 1. If we divide this f of z by z plus 1, we obtain a remainder of 0. So we are going to use this factor in order to solve and find the other roots of the cubic equation. As we said in the polynomial, we are going to substitute the value of k to be equal to 5. We said that z plus 1 is a factor. Therefore, f of z is divisible by z plus 1. So we are going to divide f of z by z plus 1. Z cubed minus z squared plus 3z plus 5 to be divided by the factor which is z plus 1. So we take the leading term, which is z cubed, divided by z squared. We multiply z squared by z cubed, z squared times plus 1 plus z squared. We subtract these two expressions, changing the signs of the terms of the second expression. So this one will be minus z cubed minus z squared. Z cubed minus z cubed, 0, minus z squared minus 2z squared. And plus 3z gets down. Minus 2z squared divided by z minus 2z, multiplying minus 2z times z minus 2z squared, minus 2z times plus 1 minus 2z. We subtract these two expressions, changing the signs of the terms of the second expression. Minus 2z squared plus 2z squared is 0, plus 3z plus 2z plus 5z, and plus 5 gets down. Now 5z plus 5 divided by z plus 1, the leading term is 5z divided by z plus 5. We multiply plus 5 times z plus 5z plus 5 times plus 1 plus 5. We subtract these two expressions, changing the signs of the terms of the second expression. So this one will be minus 5z minus 5. 5z minus 5z is 0, plus 5 minus 5 is 0. Therefore, f of z is written in the form the first factor z plus 1 multiplied by the quadratic expression z squared minus 2z plus 5.